In today's discussion, we are going to explore how energy moves through an ecosystem, and we will do this by looking at food chains, ending with an understanding of predator and prey cycles. A food chain is a simple way to represent who eats whom in a particular ecosystem. It is essentially a simplified version of a food web, as it does not include all the complex interactions among species, but instead focuses on a single linear sequence of feeding relationships. Every food chain begins with a producer, which is an organism that can perform photosynthesis. This means it has the ability to convert light energy from the sun into glucose, a type of sugar used for energy. Common examples of producers include green plants or algae. In this example, we're using a plant called Grassia, which performs photosynthesis and stores energy in the form of biological molecules. Once this energy has been locked into the plant's body, we call that energy its biomass, meaning the total mass of living biological material. The next level in the food chain consists of the primary consumers, which are herbivores that eat the producers. In our example, a mouse could be the primary consumer. Although in reality many species may act as primary consumers, including rabbits, aphids, or other herbivores, we usually only display one for simplicity. Following the primary consumer is the secondary consumer, which is usually a predator that feeds on the herbivore. In this case, it might be an owl. The pattern in the terminology here is quite clear. Primary refers to the first consumer, secondary is the second, and tertiary, which is another word for third, is the next level. Some ecosystems may go on to have quaternary consumers, and others may not even reach the tertiary level. One critical point to remember is that energy is lost at each stage as it is transferred through the food chain. For instance, if there were 1,000 joules of energy stored in the producer like grass, only around 100 joules would be transferred to the mouse, and maybe just 20 joules to the owl. This is because energy is lost in various forms such as heat, movement, and waste. When we draw food chains, the arrows between each level show the direction that energy flows, not just who eats whom, so these arrows are crucial to understanding the energy dynamics. Moving on to predator-prey cycles, this concept shows how the population sizes of predators and prey are interconnected. If we look at a graph that shows the number of field mice, which are prey, and owls, which are their predators, over time, we can observe a repeating pattern. This is known as a predator-prey cycle. These cycles show that the numbers of both species go up and down together, but with a slight delay or lag between the two. This lag is important and is described as the populations being out of phase with each other. For example, the mouse population might reach its peak before the owl population peaks. This makes sense if you think about it. When there are few predators, the prey population increases because there is less danger. This abundance of prey then supports a rise in the predator population as there is more food available. However, once the predator population becomes too high, it begins to reduce the prey population through increased predation. Eventually, there are not enough prey left to support all the predators, and the predator population begins to decline too. This decline in predators allows the prey population to recover, and so the whole cycle begins again. The key reason why these populations do not just reach a stable equilibrium is because of time delays in population growth and decline. For instance, even when there is a lot of food available, it still takes time, often several generations, for the predator population to grow significantly, as reproduction does not happen instantly. Understanding this cycle is critical in ecology because it illustrates the interdependence of species and helps explain how ecosystems are constantly in motion, driven by biological interactions and energy flow.